Are solar storms the cause of the 2024 and 2025 infrastructure damage, power outages, natural disasters, and strange weather? Solar storms are immense outbursts of energy from the sun that interact with the Earth's magnetic field and atmosphere in ways that can have profound consequences for human technology and society. They come in the form of solar flares and coronal mass ejections, carrying charged particles and magnetic fields that can disrupt satellites, power grids, navigation systems, and communications. Historically, these events have produced notable effects, such as the Carrington event of 1859, which induced currents strong enough to set telegraph equipment ablaze, and the 1989 Quebec blackout, which left millions without power when geomagnetically induced currents overwhelmed the grid. In May 2024, the so-called Gannon storm provided another modern demonstration, reaching G5 extreme levels on the NOAA scale and producing global auroras, disrupting satellites and causing GPS and radio interference. The central question for 2024 and 2025 is whether the solar storms experienced in this period are responsible for some of the observed disruptions to infrastructure, power outages, and even claims of unusual weather and natural disasters. At first glance, official reports and media coverage often attribute blackouts to routine causes, such as equipment failure, poor maintenance, or fuel shortages. However, the absence of a public statement connecting an event to solar storms does not constitute proof that no connection exists. Silence is not denial, it is simply missing information. By contrast, the Gannon storm is a concrete data point showing direct impacts. Thus, the logical conclusion is that solar storms remain a plausible contributing factor to 2024 and 2025 disruptions, even if not publicly acknowledged. Scientific and engineering studies reinforce this view. The Royal Academy of Engineering, in its report on extreme space weather, emphasized that modern infrastructure is highly vulnerable to geomagnetically induced currents. Transformers can overheat and fail, long transmission lines can carry damaging surges, and coastal or geologically conductive regions face even greater risk. Satellites in low Earth orbit are threatened by atmospheric expansion that increases drag, leading to unexpected orbit decay and fuel use. The European Union Council's 2023 report stressed that as society relies more on GNSS navigation, satellite communications, and electrical grids, the risk from solar storms grows. The 2014 analysis in Nueva Tribuna likewise warned that while severe solar storms are rare, their potential to cause systemic technological collapse in modern conditions is severe and not fully appreciated. When we examine the 2024 Gannon event in detail, the physics of the disruption is clear. Energetic particles heated the upper atmosphere, causing thousands of low Earth orbit satellites to lose altitude, forcing emergency maneuvers. GPS accuracy degraded enough to disrupt precision agriculture and other industries. The GOES-16 weather satellite temporarily ceased transmitting data. High-frequency radio signals became unreliable, especially near the poles. Voltage fluctuations were recorded on some power grids. These are not speculative claims, they are documented observations. Therefore, the causal chain from solar activity to technological disruption is scientifically robust. If this causal chain held true in 1859, 1989, and 2024, then it must also apply in 2025 when comparable or stronger storms occur. Physics does not change. Yet the narrative gap persists. Power outages in Ecuador in June 2024 were attributed to transmission line failures. Cuba's blackouts were blamed on plant breakdowns and fuel shortages, and outages in New York were linked to poor vegetation management and aging infrastructure. These explanations may be true, but they do not exclude solar influence. A transformer weakened by years of neglect may fail under the added stress of geomagnetically induced currents. A grid operating at its limits may collapse more easily during solar disturbances. In such cases, both the terrestrial and the solar factors play a role. The same reasoning applies to satellites and navigation systems. If satellites were already struggling with debris avoidance or limited fuel reserves, a solar storm-induced drag episode could tip them into critical failure. If GPS systems were already strained by demand, solar-induced ionospheric disturbances could push errors into operationally unacceptable ranges. When aviation or shipping reports navigation anomalies in 2025, even if not officially linked to solar storms, the possibility remains real. Silence from operators or governments does not equal proof of no effect. The logic model is simple. Silence is not denial, it represents unknown status. Independent events like the Gannon storm are contradictory data points proving real effects. Contradictory data outweighs silence. Therefore, absence of statements does not disprove connection. Applying this model shows that 2025 events must be evaluated with openness to solar involvement. Critics may argue that claims of links to extreme weather, earthquakes, or volcanic eruptions remain unsubstantiated. Indeed, scientific consensus holds that solar energy does not penetrate to Earth's crust to trigger geological events, and long-term climate change is driven primarily by greenhouse gas emissions, not solar variability. Yet even here, nuance is important. Some peer-reviewed studies explore regional correlations between solar activity and short-term phenomena, such as the Indian monsoon or tropical cyclone frequency. While no robust causal mechanism is established, the research continues, showing that the field is not closed. More speculative claims should not overshadow the well-established connections, but neither should they be dismissed out of hand without further research. The broader challenge is bridging the gap between physics and narrative. Governments and agencies like NOAA and ESA do issue regular space weather alerts, and engineers and scientists acknowledge the risks. Yet public reports of infrastructure failures seldom mention solar storms. This may be due to habit, institutional silos, or reluctance to acknowledge systemic vulnerabilities. The result is that the public perceives solar storms as distant or irrelevant, when in fact they are a live risk. Preparedness requires more than monitoring. Utilities should install geomagnetically induced current monitors, harden transformers, and integrate space weather forecasts into grid management. Satellite operators must build resilience into their fleets, plan for drag events, and diversify navigation systems with backups such as ELORAN. Aviation and shipping must prepare for HF outages and GNSS disruptions. Governments should include solar storms in national risk registers and public education campaigns. The conclusion is unavoidable. Solar storms are proven to cause technological disruptions. The Gannon event of 2024 is the latest modern demonstration. As solar activity peaks in 2025, it is logical to assume that some of the infrastructure damage, power outages, and anomalies being reported are influenced by solar activity, even if official reports do not confirm it. Silence is not proof of absence. The correct academic and scientific stance is that the issue remains unresolved, but strongly suggestive. Solar storms must be recognized as plausible contributing factors to 2024 and 2025 disruptions, and preparations must be made accordingly. Therefore, the answer to the question is that solar storms are not only possible, but likely contributors to the infrastructure damage, power outages, and anomalies of 2024 and 2025. They are not the sole cause of all events, but they are part of the causal network. Ignoring them due to absence of public statements is a logical error. Recognizing them allows for better understanding, stronger infrastructure, and greater societal resilience in the face of cosmic forces that we cannot prevent but can prepare for.